Okay, let's pick up here where we left off. So we loaded in our data, and what we want to do next is create what's called a survival object. And this is basically it's putting the data in the format that these particular packages want them to be so we can conduct the proper analysis. So we are going to call this survival object. And the way to do this is we're using this serve function. And so what we're doing here is telling the object where the survival time is located within our data. And so for us, it's in our abalone data that we loaded, and it's specifically in this survival time column. And that is all we need to provide. So we will execute that. Now we've created our survival object that has indicated where the survival time data is for each different individual. The next thing we need to do is fit. So in this particular lab, the type of survival analysis we're doing is fitting a Kaplan-Meier survival curve. We don't need to go into the statistical details for this particular lab. I have a link to a tutorial in the written out lab instructions to give you some additional background info with this particular type of survival curve analysis if you are interested. But for our purposes, I'm going to gloss over that and focus more on the actual, what we actually need to do to perform this type of analysis. So we've created our survival object, and what we need to do next is fit those Kaplan-Meier survival curves by passing that survival object we just created to a different survival fit function. So we're going to call this fit1, and what we're going to do is use this survive fit function, and we're going to use that survival object we just used, and what we want to do is tell it which variable within that data set is what's separating out the different population or the different groups that we're comparing. In our case, it's the farm that we're comparing. We're comparing the cultured abalone, or CA, to individuals from MAC, or Monterey Abalone Company. So we will do that and then tell it that the data overall that we're using is this AB data. Let me make sure I didn't type in anything incorrectly. I think we are good to go, so we'll execute that. Now we've created our fit1, and what we can do now is look at that in a summary format, and that'll open up this in your bottom console here. And so what this is showing us is two different groupings in this table. The first one is for cultured abalone farm, and the bottom one is for Monterey Abalone Company. And this summary tells us a couple different things. The first thing that I would like to point out is it tells us overall how many individuals are alive at the end of the experiment versus when you started. So if we start here with cultured abalone farm, at the end we only have 2 individuals surviving, but we started with 6. So that information is in this n.risk column, and it's showing us overall we started with 6 individuals, only 2 of them survived. In contrast, for Monterey Abalone Company, we started with 10 individuals, and actually 8 of them were still alive at the end of the experiment. So basically each row here in these tables is indicating an event, which is a mortality event. So every time one individual died at a particular time point throughout this monitoring period, that adds a new row here in this summary table. The other thing to note is that the survival column here keeps a running proportion of how many individuals are alive at each of these time points. So here at our first event, where we have the first individual dying, which is on day 16, so that's this far left-hand column here, the time, it's giving the day throughout that monitoring period when each respective individual died based on the data that we gave it with the survival time. So here at that first time period, we see we're down to about 83% survival. And by the time we get down to the last event where we have only 2 of 6 individuals surviving, that means our survival is down to 0.33 or 33%. In contrast here with the Monterey Abalone Company, we see that overall it only gets down to 80% survival because we end up having 8 out of 10 individuals still surviving at the end of the experiment, at the end of the monitoring period. So this is an example of once you've fitted those survival curves, the information it can give you in terms of how many individuals are still alive versus how many you started with, and also what the proportion of surviving individuals is. And then in the next video, I'll cover how to actually visualize that and how to perform a statistical test that'll give us a p-value to tell us whether or not the survival curve is significantly different in these 2 different farms.